In section 7.4, we're looking at inverse functions. And inverse functions are going to just swap our x and y terms conceptually. So you might see some problems where I give you a list of coordinates x and y. We're literally going to switch them. The purpose of this particular tutorial is to look at both the algebraic solution as well as what it means graphically when we do that. All right. We're going to start with a linear function, one whose slope is 3/5 and has an intercept of 1/5. And I want to show you both what this looks like graphically and algebraically. We're going to start with the graph of this function really quick. And we know that the slope is 1/5, 3/5, and it goes through a y-intercept of 1/5. So 1/5 is about here, and let's just draw a line here. And we want to go up 3 and over 5. Something about like this. I'm going to go ahead and extend this line. Okay, and so there's our first line, and I'm going to go ahead and make that red for us for the purpose of this discussion. We can see where it goes. Okay, let's go ahead and algebraically solve for the inverse. What I'm going to do is switch the variables. So x equals 3/5 at y plus 1/5. And the reason we do this is because the inverse is defined as a function whose outputs become its inputs. So, all right, now we need to solve for y so that we can graph this. And the reason we reverse these is so that we can see them on the same set of axes. So I see a common denominator here of 5. So I'm just going to multiply my entire equation by 5. What I'm going to be left with is 5x equals 3y plus 1. Now I'm going to subtract 1 from both sides and just solve for y really quick. I'm going to also switch sides and put the 3y on the left. I like my y's on my left. I just flipped everything over, so the 5x is on the opposite side of the y, as is the minus 1 now. And I'll divide by 3, and it's important here that you divide the entire quantity on the right by 3, and we get y equals 5/3 x minus 1/3. So a couple things you'll note there. Take a look at the slope. The slope is 5/3 when before, okay, it was 3/5. So we do invert those numbers a little bit, but in this particular case we haven't changed the sign. So let's go ahead and see what that looks like. It's going to be a slight negative y-intercept of 1/3, and then I'm going up 5, 1, 2, 3, 4, 5, and over 3. Okay, and I'm going to extend this line and make it blue too. 1/3. There we go. So what we have with this line is one that is mirrored. Now I'm going to throw in a line in here really quick because we've gone ahead and done this algebraically, but there's a way in which you can do this such that you are looking at it from a geometric standpoint. My lines are close. This is the line y equals x. Okay, right here is y equals x. And that's what we did, was we switched those two variables, x and y, in our equations. So what you can see is that our original line, the one that's in red, then becomes mirrored or reflected through y equals x. Okay, and our new line looks like it causes the y equals x line to split it. Okay, so you could literally find a point over here, reverse the coordinates, and they would be over here on this line. Let's take a look at one more problem, and one that isn't linear. So we're going to do the same process, but first let's just take a look at what this thing looks like when we graph it. 2x squared is going to go through the origin. This is a parabola, okay? Um, and so we just know that if we take 1 and square it, we get 1, and multiply it by 2, we're up here, okay? And the same thing would be true over here, okay? And if I took 2 and squared, I'd get 4. N times 2 would be 8. We're way up here already, okay? And over here. So we get a parabola. Let's see if I can draw a parabola on here. It's a horrible parabola. Give me a second. Okay. See if I can draw a parabola that looks like a parabola. Something like that. And let's see what is going to happen when we try to reflect this guy. All right, that's a little better. So let's do this algebraically. Let's switch our two terms and solve for y. Okay, here we're going to divide by 2 first. Remember, you want to isolate the variable even though it has an exponent, but you got to get it by itself before we can do a square root. Now I'm going to switch sides here, so x squared equals x over 2. Now I'll take a square root of both sides to undo that square. And what's left over here is y equals the square root of x over 2. Okay, and that 2's inside the radical there. All right. Now, this one may be a little harder to just plot points on, okay? But what we're going to do is I'm going to try to reflect this through the y-axis and see if we can draw it that way. Let's not forget that there's actually 2 here. We've got a positive one and a negative, okay? So what this one's actually going to look like, let's draw our line y equals x again here. There it is, y equals x. And this is simply going to be rotated through it. It's going to be the same shape, but everything reflected. So I'm going to use technology a little bit here, and we're going to clone this. We're going to change its color because our new line is blue. There we go. And I'm simply going to rotate it 90 degrees. And we know that it gets reflected through this point here. So our line's actually going to look just like that. Okay, if we had 2 ugly squiggly lines like mine. Okay, and so what you'll see is that this point right here gets reflected to this point right here. If we went over 2 and up 8, the same would be true of going out 8 and up 2. The same thing is true when we're reflected down. Okay, so everything gets mirrored through there, right? So we could plot our points. I went ahead and just duplicated it and drew my line and realized that it's an exact reflection through that line, so that we know what that looks like. Very quickly, I just want to grab a red line here. I'm going to draw a big red vertical line. Okay, I'm going to slide it over. We can know that our first function, y equals 2x, is definitely a function because it passes the vertical line test. As soon as I come over here into the second equation, though, our inverse, we realize that the whole function is not a function. If you take a look at the positive half, or just the top, that is a function. If you take a look at the negative half, the bottom, each one is a function. But together, the inverse of y equals 2x squared is not.